Okay, question 14, classical binary search. Given a target integer t and an integer array a sorted in ascending order, find the index I such that ai equal to t, or return -1 if there is no such index. So here the function is binary search, and there are two data input. One is int array and another one is integer for the target. And the return type is integer. Basically, it's the index of the target integer. And the assumption here is that the input array is sorted and in ascending order, and they can be duplicate elements in the array. And possible corner case for this is when the array is null or the length is 0. When that happens, we just return -1. And the solution here is the binary search. Basically, we set out the left-right pointers to define the search range. And then we have a while loop. Whenever there are elements within the search range, we find the me index and then compare the me element to the target. And based on the result, we reduce the search range by half until we find the target integer. And if we don't find it, at the end, the left pointer will be greater than the right, and then we stop the loop and then return -1. Okay, now looking into the code. The first part of the code is sanity check. First, we check if the array is null or not. Then the second, we check if the length is 0. If any of these happens, we return -1. And next is to set out the pointers left and right. Left start with 0 and the right is the biggest index of the array. And then we set up the while loop. The condition of the while loop is left less or equal to right, meaning whenever there are elements between this search range, we need to do the binary search. And to do that, first we try to find the me index, and then we compare the me element to the target. If it's equal to the target, then we find the index, we return the me. Otherwise, if the me element less than the target, then we know the target is in the right side of the array, then we move the left pointer to me +1. Otherwise, we move the right pointer to me -1. At the end, if we don't find the target integer in this search range, at the end the left will be greater than right, then we stop the loop and then we return -1. Okay, and then the time complexity of this function is log n because we reduce the search range by half in each iteration. And the space complexity is O1 because in each iteration we don't create a new variable or we don't create a new object.